Hello, what is going on? Time is 2 o'clock. Hopefully, I'm not going to make any silly mistakes. All right, if I make any mistakes, I'm so sorry. But I'll make sure that I will make the answer available for you to look at, right? Okay, this question 2, is mainly based on calculations, but it is not the most easiest question. So you have to be careful of doing questions like that. It is difficult, right? But when you get your head around this, when if you end up getting a similar question to this, you'll be able to do that, right? And definitely, this question requires for you to use ICE method, ICE table, right? Are you good? All right, let's go to question 2. Now, as you can see, the question 2, it says 9 marker between hydrogen and I2 producing 2HI. Case is given to you at 400 degrees. However, the question does not tell you whether it is exothermic or endothermic, right? Okay. Now, according to this question, if HI concentration at 400 degrees, if the HI concentration at 400 degrees in an equilibrium mixture resulting from an addition of equal mole of hydrogen and I2 is 10 of IM. Now, the way the question is presented is so difficult to understand. Even I find it difficult to understand. Look, the question is saying about the concentration of HI at 400 degrees is given to you, which is 1.05, right? Which is 1.05. They are saying that concentration of HI, which is 1.05, is achieved after adding of equal number of moles amount of H2 and I2. Okay. Now, question is asking what was the initial concentration of the iodine in the reaction vessel. Okay. Now, in order to do this question, as you can see, you have to do this question using what? Concentration. In the ICE table, we are going to use initial concentration, change in concentration, equilibrium concentration, because here it is the equilibrium concentration. You cannot do this question using number of moles because why? Because you don't know the volume. All right, so let's try to do this question uh, using ICE table. So what do we do? You draw a ICE table. Okay. uh, Now here we go H2, I2, 2HI. Now I'm going to do this question using concentration. So initial concentration, change in concentration, equilibrium concentration. Now, okay, according to this question, only information you can gather is the concentration of one of HI at equilibrium, which is 1.05. See, that's the only thing. That is the only information that is given to you. Other than the fact that they are also saying you are using equal amount of, you have used equal amount of hydrogen and I2 at the beginning. Okay, so in order to do this question, what we are going to do is this. So initial concentration we don't know, but we know that since they have added the equal amount of moles or same number of moles of H2 and I2, we know that initial concentration of H2 and I2 is the same. Okay, let's say that is X, because we don't know. All right, that is X. Then I2 concentration at initial, it's X. HI concentration, I mean at the very beginning there are no HI, so initial concentration of HI is 0. Yeah, is that clear to you? Because there are no HI at the beginning, because you are starting the reaction by adding hydrogen and I2 together. So there at the very beginning there is no HI. Is that clear? That's why it is 0. Now, okay. Now then again, let's say the y amount of Hi and I2 is reacted, or y amount of the number of moles. Okay, let's say concentration change. Concentration change of H2 is y. So minus y, this is minus y, then this is 2y, isn't it? So the equilibrium amount is what? X minus y, x minus y. Now that's all uh, what we can use in the ice table. All right. Now we need to find out x. What is x minus y? If you know x minus y, you can work out what is x, because we know what is y, because look, it is here 2y. 2y is equal to 1.05, right? Then we know what y is. You know what change is. Change in concentration is 1.05 divided by 2, which is 0.575 moles per liter. We got y. All right. Now we need to, if you can find out what is x minus y, Bob's your uncle. If you know the x, if you can find out the x minus y using equilibrium expression, Bob's your uncle. You can find out the x. X is what? It's the initial concentration, right? Okay. Now we are going to find out what is x minus 1 using equilibrium expression. All right. Let's see how we can do that. Now, in order to do that, you need to write the equilibrium expression, which is the equilibrium constant, which is 40.52. There's not enough room here. How do we do that? HI concentration squared, which is 1.05 concentration squared over x minus y look, x minus y times x minus y. Is that clear to you? So which is the, okay, x minus y, isn't it? Because they're the equilibrium concentration of both H2 and I2 the same. So instead of doing that, x minus y times x minus y, we are not going to use quadratics. We simply say x minus y squared. Now, so using that formula expression, we can find out what is x minus y is, which is what? 1.05 squared over 45.2. You have to rearrange and you need to find the square root. Is that clear? You need to find the square root. If you do that, 1.05 squared over 4.2, and when you find the square root, which is what? Which is going to be 0.156 moles per liter. Now, what have we just done? We just found out what is x minus y is. Now we already know what y is. You see, we already know what y is. Now you know x minus y. Now you can find out. So what x is? X is the initial concentration. So what you need to do? X minus y is going to be equal to 0.156. Then x is equal to 0.156. We know the what y value is, which is 0.575, isn't it? 0.575 or 525. 575 or 525. Let me check. Y is, oh, my mistake, it is 525, man, not 575. 525. That is going to be equal to, look, I've made a mistake over there. That is going to be equal to 0.681 moles per liter. 6.1 moles per liter. Now listen, if you could do that question, man, your mathematical skills are really good in terms of equilibrium mathematical skills. This is really math-based question, wasn't it? Right? There are no explanation, nothing. You just had to use maths in understanding, doing this question. But you need to have an understanding of equilibrium principle as well. All right, let's look at the next question. And then again, that question is also it's also really a good question, right? I haven't seen that sort of a question in Vika lately. So let's see how we can approach part B of this question. In part B, as you can see, what is the question is asking you. At 800 degrees, the value of Kc for the equation is given to you at 800. Now, look, previous one is 400. Now they are asking us to give the no, they have given us the Kc value of the reverse reaction. You see that? Reverse reaction at 800. So tricky, isn't it? They have given us the Kc value of Kc value of Kc value of the reverse reaction at a higher temperature. See how tricky this question is. Okay. Now, then what's the question asking you? Explain how this enables you to deduce the thermochemistry of this one. Now, so they are asking you, hey, what is the thermochemistry? Thermochemistry is they are indirectly asking you whether this reaction is exothermic or endothermic. Is that clear? Exothermic or endothermic. So how do we work that out? In order to work that out, what you need to do is you need to find out the Kc value. Kc value of this reaction. Kc value of this reaction at what? 800. Couldn't we use that? No, you cannot use that because that is the reverse reaction. So if you can find out the Kc value at Kc value for the for the reaction H2 plus I2 making 2Hi, which is same as that, which is 400, which was that 400, which is 45.2, then we can work out whether this reaction is exothermic or endothermic. Okay, let's try to find out the Kc value for the reverse reaction. So let's say Kc2 at 800. In order to do find out the Kc2, what do you need to do? Now you need to compare this reaction and this. So that's the reverse of the one that the Kc value is given to you. All right. So in order to do that, you need to find out the Kc value at 800 for this reaction. So what do you need to do? Okay, let's say it is Kc2. Reverse means 1 over square root, isn't it? 1 over 0.0174 is the Kc value for the reverse reaction, which is what? Which is 57.5. 57.5. There are no units. Now look. Now what have we done? Okay, now what have we done here? All right, now what I'm going to do, I'm going to summarize what we found in the table, right? So by looking at that table, we are going to see whether this reaction, or not whether we are going to see, by looking at this table, we are going to compare the Kc value from at 400 to 800. Then we are going to determine whether this reaction is exothermic or endothermic. All right, let's see how we can do that. Okay, I'm going to draw a table. So in that table, temperature, temp, and Kc value for the reaction. What is the reaction? H2 plus I2 making 2Hi, right? That's the reaction. Okay, temperature 400. Okay, we've got that here, which is 45.2. 45.2. Okay, at 800, we just found that at 800. See, at 800, was that? 57.5. Okay, now what has happened? When you increase the temperature, Kc has also increased. So when you increase the temperature from 400 to 800, Kc has increased. What do you think what has happened? In order for Kc to have increased, the forward reaction has happened. So when you increase the temperature of the system has favored the forward reaction, because in order for Kc to go up, you need to be producing more product, less reactant, then the Kc will go up. In other words, what has happened here? The forward reaction has happened when the temperature is increased. So what would the system do? System partially oppose the change by trying to, when you increase the temperature, system will partially oppose by trying to decrease the temperature by by uh, by trying to decrease the temperature. System has favored the forward reaction. So the forward reaction should be endothermic. The forward reaction is should be endothermic. Okay, that is what you have to work out. It's a 2 mark. So let's try to write a answer here. So what do you have to do? When temperature is increased from 400 to 800, right? Kc has increased. Therefore, net forward, we say net forward reaction has favored, right? Net forward reaction has favored. Is that clear to you? So net forward reaction has favored. Okay. Net forward reaction has favored. All right, forgot to switch the camera here. So when temperatures increase from 400 to 800, yeah, so net forward reaction has favored. Okay, let me say that again. When temperatures increase from 400 to 800, Kc has increased. Therefore, net forward reaction has favored. Okay. According to the LCP, when temperature is increased, system favors the endothermic reaction. Therefore, forward reaction is endothermic. Is that clear? All right, this is a good question, isn't it? Huh? It is really a good question. Hasn't seen a question like in Vika, because the tricky part is you need to find out the new Kc value for this reaction at 400 using the Kc value, not for 400, maybe say for 800, right? Using the Kc value for the reverse reaction, which is given to you at 800. So too much stuff happening here. So that's the way to do this question, right? All right, now let's look at the next question. Where you have to draw concentration time graph and rate time graph. Now in this case, you need to do the rate time graphs. Rate time graphs are difficult to understand, so I need to do a lesson or a short lesson where we discuss rate time graphs. Concentration time graphs, quite easy. You can understand them quite easily, but the rate time graphs can be a bit difficult. Okay, so let's see how we go when it comes to this question, right? All right, but before we do that, it's better that we rewrite the question. H2 plus I2 going to become 2HI. Okay, now, so here, what are we doing? What is the change on the graph? Show the effect of doubling the volume. We know that when the volume is double, concentration of all of these species, which is that there are dotted line, will decrease, right? Decrease. Concentration of all the species will decrease. When you are doubling the volume, concentration will be halved. Now the thing is this, okay? So we are okay. You have increased the volume. You have doubled the volume. When you double the volume, pressure is going to be halved. pressure is going to be halved. So then what would the system do? System partially oppose the change. So system partially oppose the change by trying to increase the pressure. Then what would the system needs to do? System will favor the side with more particles, because more particles means more pressure. But unfortunately, here system will not be able to make any changes to the system would not be able to partially oppose any of these any of the I was meant to say system cannot partially oppose the change here, because why? Have a look at that. Both side has got the equal number of particles. Therefore, equilibrium is not uh, so system will not partially oppose any would not oh man system will not be able to partially oppose any of these changes. Therefore, there is no what? There is no shift to any direction here. There is no shift, right? By adjusting the equilibrium, there is no shift. All right. Sorry about my sorry about it's almost 2:30. Okay, so how would you show that in the equilibrium concentration graph? Let me show it to you. So system is unable to make any changes. So what will happen to the concentration? This concentration stays the same. The concentration stays the same. All right, now let's look at the rate time graph. That can be something totally new to you. All right, so what do you think what will happen to forward and the reverse reaction? Forward and the reverse reaction rate when you increase the volume. As you know, when you increase the volume, suddenly both the forward and the reverse reaction rate will decrease straight away. Why? When you increase the volume, reactant particles are going to be further away from each other, so the frequency of successful collisions will decrease. That is why both the forward and the reverse reaction will suddenly decrease. Make sense? All right, now what do you think what will happen? Do you think the forward reaction will pick up or the reverse reaction will pick up? No, in this case, because there are no shift to the equilibrium. Both the forward and the reverse reaction rate stays the same after that. That is what you need to do. All right, so I have done that question. Okay, I've done the part 1. Explain this response to the volume increase on equilibrium mixture H2 and I2. So in equilibrium mixture, explain this response. Okay, on both graphs show the effect that doubling the volume equilibrium mixture would have. Explain this response to volume increase. Okay, I think we've covered that. So what do you have to say? All right, we need to write that as well. Okay, let's try to write this down. When the volume is increased, when the volume is doubled, when the volume is doubled, what will happen? Pressure is halved. System partially opposes the change by trying to increase the pressure. Increase the pressure by favoring. Increase the pressure by favoring the side with more particles, right? However, as there are equal as there are equal number of moles, equal number of moles, as there are equal number of moles on both sides, on both sides of the equation of the equilibrium, both sides of the equilibrium, the system cannot adjust. The system can't adjust. System cannot adjust to increase the pressure. Therefore, pressure. The system remains at equilibrium. Then what? Increase the pressure. So we said that system cannot adjust. So pressure, therefore, so we said system cannot adjust to increase the pressure. So therefore, concentration of the pressure or the pressure remains same. Concentration or the pressure does not change. Doesn't change. Remain same. All right, that's what you need to do. That's one mark to say that. I know it's a bit of overkill, but similarly, I mean, you need to say why rate does not change. Similarly, the rate of the forward, and reverse. Rate of the forward and reverse decrease due to increase in pressure. You have to say due to, as a matter of fact, you have to say you are increasing the volume. So what will happen in terms of the rate? You have to say the concentration of these particles will decrease due to, right? Is that clear? Due to concentration of the reactant decreases. What? Decreases. This decreases, but there is no change. But in this situation, remains equal. I mean, that's a good question, and this is a good question. I think you want. I think it's better if you can if you can try this question several times, especially the explanation part. Okay, I will make the answer available for you to go through this again. All right. Now it's almost 2:30. I'll see you with another question tomorrow. Thank you so much. I'll see you soon. Okay. Bye bye.